Okay, so I'm going to now talk for a little bit about isotopes. So when we talk isotopes, essentially what we're talking about are different variations of an element. And these variations have to do with the way of thinking of it is how heavy or how light they are. So going back to carbon, we see carbon atomic number is 6, which means that it has 6 protons. And carbon will always have 6 protons. Because that's what makes carbon carbon, is having 6 protons in that nucleus. So we'll start with kind of looking at one of our simplest examples. So in a carbon atom, we know that there's 6 protons. We also have neutrons. Each of those, we say, has a mass of 1. We're talking atomic mass units, AMU. So let's start with one that has 6 neutrons. So what is the mass? Mass is equal to 6 from the protons plus 6 from the neutrons. So we add that up, we've got 12. We notice that 12 is pretty similar to what's on the periodic table. But let's look at something that's a little bit different. We're going to look at, so we're still carbon, so we still have 6 protons. But what happens if we have 8 neutrons in the nucleus? So, what is that? Well, here's the first thing we need to look at. 6 protons. So that tells us that it is still carbon. And so this atom will do exactly the same things chemically as this atom over here. Because 6 protons, that's what makes it carbon. So for the mass, we still have that 6 from the protons. And now we have 8 from the neutrons. So when we add that all together, 6 plus 8 gives us 14. 2 identical atoms of carbon. Sorry, not identical. 2 atoms of carbon, 6 protons. This atom has 6 neutrons in it. This atom has 8 neutrons. As you might expect, 8, a little bit bigger. All neutrons do, they basically, it's like just throwing weight onto something. Just makes it a little bit heavier, or if you take them away, it makes it a little bit lighter. The chemistry of it, of what that atom does chemically, is all based upon these number of protons, which makes it carbon. So chemically, this will react exactly the same as this. So how can we kind of differentiate and tell these apart? So different ways that we will see these isotopes written. You might see it written long ways. Carbon, and then the mass. So you would see this written as carbon 12. You might see just the symbol used. C-12 for carbon 12. Carbon with a mass of 12. And then we can also see it written in this convention, where you use the symbol, mass in the top left, atomic number in the bottom left. You could see it written with just the 12 in the carbon. And the reason being is that the 6 down here in the bottom left isn't necessarily needed It's a little bit redundant because carbon has 6 protons. So over here then, for this, what would this be? Carbon with a mass of 14? Carbon 14. Used for radio dating. Or maybe written C. 14. 14, written this way, 14C6, or possibly 14C. And these four are just to present you with different ways that carbon with a mass of 12, 6 protons, 6 neutrons, could be written any of these ways, and carbon 14 could be written in any of these ways. So it's either the name and the symbol with the mass following it, or we put the mass in the top left. And that is how we differentiate and write down the different isotopes.